This video demonstrates our notion of centrality derivatives for visualizing social networks. Our first application is friend and enemy visualization. This visualization encodes the magnitude and sign of centrality derivatives with color and transparency. When we plot only positive derivatives in green, we clearly see a separation of the different clusters in the network. When we plot only the negative derivatives, we see the connections between clusters. This example shows a node link diagram of a protein network. Color lets us discover groups of nodes with strong negative or positive ties. Our next application is simplification of complex networks. Node link diagrams are difficult to understand, often resulting in hairballs. This example shows a network of influence between great thinkers in history. We can obtain a core network using the minimum spanning tree of the graph, using the centrality derivatives as edge weights. The resulting view is much clearer and retains the relative importance of central nodes. Adding back important edges to the tree gives us a simplified network that links the most important actors in the core network and retains the centrality of the important nodes. We see, for example, that the most important nodes remain at the center of their local clusters. When we apply this technique to a protein network, we begin to discover structure. The resulting spanning tree provides a clearer view of the network. Now it is possible to see distinct clusters of nodes. Now we add some important edges to the tree to recover the core network and explore some of the discovered clusters. Derivatives of centrality are also useful for exploring the important nodes relative to a focal point. Red and green indicate a node with negative or positive influence to the focal node. Saturation indicates the strength of the link. Looking at this cluster, we discover an important node, which happens to be a bridge between centers of other clusters. Further exploration helps us discover important connections between clusters. Finally, centrality derivatives also let us visualize the uncertainty and reliability of various metrics. Here, larger nodes are more important, and larger rings indicate more uncertainty. The correlation between high centrality and low uncertainty indicates good reliability and robustness of the centrality metric. It also helps us identify weak links in the social structure, such as these small nodes in the upper cluster. This concludes our demonstration of using centrality derivatives in the visualization of social networks.